just spinning on its axis, it's also revolving around the sun. So as the Earth moves around the sun, the seasons change, from say winter to spring, or in the southern hemisphere, summer to fall. And as the seasons change, so do the constellations that are visible at night. So several months later, you're now seeing these stars in this part of space. And as the Earth continues around the sun, the seasons change from spring to summer, or fall to winter in the south. And these stars are now visible to us at night. And
you can't see Orion in the summertime because the sun is right in front of Orion. Okay?
Allegedly.
But I mean, like, literally, there's no June where anyone's seen, I don't know if it's exactly June, but whatever's opposite of December, right?
Greetings and welcome to the Introduction to Astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website that is apod.nasa.gov/apod. And today's picture for June the 9th of 2020, well, it is titled Orion over Argentine Mountains. So what do we see here? Well, we are looking at the constellation of Orion up in the sky.
I'm going to prove that the Globers do not understand the heavens like they think they do. I've touched on this in the past, but I've got thorough supporting evidence. Now, in my opinion, this is the #1 globe killer, which is ironic because the Globers treat stars as one of the top globe proofs. But to bring everybody up to speed, this is about Orion, which is a constellation at the equator. It's directly over the equator and it spans north and south of the equator. Now, the reason I picked a constellation directly on the equator, if you look at the model on screen, I know it's not to scale, but if we say that summertime, Orion is opposite the Earth behind the sun. So Orion in the summertime is directly behind the sun. That means 6 months later, it should be exactly opposite of the sun. Okay, I'm going to expose the dirty rotten trick here. Picture a clock. Now that clock represents a 360 degree equatorial field of view throughout the year. So picture 12 o'clock is Orion and 6 o'clock is the sun. The Earth is in the center. So Orion is exactly opposite of the sun. So the sunlit side of that clock represents 3, 4, 5, 6, 7, 8, 9. That's 7 months. So that's a little over 180 degrees, but we'll give it to them. So Orion being 12, what they're trying to do, so if it moves over, so 1 month later, it should be the daylight side should be 4, 5, 6, 7, 8, 9, 10. And then another month, it should be 5, 6, 7, 8. It should move over one every month. So the way they have it is in December, okay, if the sun is 6 o'clock, they say in June that the reason we see Orion is because of the Earth's tilt. So because of the Earth's tilt, we're able to see 3, 4, 5, 6, 7, 8, 9 and squeeze in 12. So forget about the sun. They're squeezing in Orion with the normal 180 degree field of view. Okay, and I really, to be honest, couldn't find one entire month that Orion wasn't visible somewhere on Earth. So there's something going on, because in the summer and the spring you could see Orion from and I'm going to show examples in the southern hemisphere.
Orion can be seen from both the northern and southern hemispheres. In the northern hemisphere, the constellation can be seen from late autumn to early spring in the southwest night sky. In the southern hemisphere, Orion can be seen in the summer months, visible inverted in the southwest sky. In both cases, it is seen rising in the east and setting in the west.
Greetings and welcome to the Introduction to Astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website that is apod.nasa.gov/apod. And today's picture for December the 25th of 2020, well, it is titled Northern Winter Night. So what do we see here? Well, we see an image of the winter sky as taken in the northern hemisphere, and one of the most prominent constellations in the winter sky, and one that many people can also often identify, is the constellation of Orion, which we see right towards the center of this image. 3 stars in the belt, and then other stars outlining the
Sun rises in the east as a general rule and sets in the west. Think of Orion as a nighttime sun mimic. That's basically how this works. So now, if we look at this image, as you can see, it's pretty close to the horizon, yet it's almost vertical. From this, one can conclude that this photograph was taken at a very high latitude in the northern hemisphere, probably the top.
They claim that we don't see the stars through perspective. Well, how do you explain this on a globe? Orion here, standing upright, as viewed from the far northern latitude, just like every other constellation. So I know they must have went to the North Pole to lay out all the constellations. No, this doesn't work on a globe except for through perspective. But if you use perspective, it kills their model. Another flat earth proof.
Norway or somewhere like Iceland as an example. So that is Orion in a nutshell. We know how it travels across the sky in high, medium and low latitudes in the northern hemisphere. We know why.
Another example of perspective is the further we get from the equator to the far north, the less distance the equatorial stars seem to be covering. That's perspective.
Travels across the sky with a similar motion to the sun, and we know how to analyze it to find directions. What else can we talk about? Well, let's talk about the ever-changing window for observation. Orion is a seasonal constellation, meaning it will only be visible or partially visible during certain seasons. It's regarded as a winter constellation because during the winter it completes the full visible cycle from east through south to west. As winter transitions into spring, it only becomes visible in the south and sets in the west. From mid-spring through to summer, it's not visible at all. The constellation becomes visible again in the late autumn, appearing in the east and disappearing into the south, until winter.
That's the same thing Bob the science guy told me and McToon referred to, that you can't see it during the summer. Can't see Orion during the summer. But there's conflicting information all over the place.
Greetings and welcome to the Introduction to Astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website, that is apod.nasa.gov/apod. And today's picture for July the 6th of 2020, well, it is titled M43, Dust, Gas, and Stars in the Orion Nebula.
Greetings and welcome to the Introduction to Astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website, that is apod.nasa.gov/apod. And today's picture from March the 29th of 2020, well, it is titled A 212-Hour Exposure of Orion. Greetings and welcome to the Introduction to Astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website, that is apod.nasa.gov/apod. And today's picture for February the 18th of 2020, well, it is titled Orion over the Central Bohemian Highlands. So what do we see here? Well, the image of the sky is one of the most prominent constellations that we see, and that is the constellation of Orion. And that is one of the better known constellations that people can often identify. Now, there are a number of objects here that are visible.
So you heard the professor using NASA's website showing Orion visible in all these spring months and summer months when it shouldn't be visible. Okay, the only thing we know about the stars is what we could prove empirically. They follow a pattern. They change about 1 degree every 69 miles or 60 nautical miles. That is not exclusive to a globe. They want to place the stars damn near infinite distance away and claim geometry. That's horseshit. You see that the stars follow some sort of perspective. You know, we don't fully understand it, but that could only work on a flat Earth. So the best thing we could do is put our heads together and make sense of it all. But I think I've proved with room to spare the globe fell with the stars.